Open any AI agent tutorial on YouTube right now. Within the first 2 minutes, you will see someone open a Jupyter notebook. They will do pip install OpenAI, write maybe 30 lines of code, call it an agent, and title the video, "I built an AI agent in 5 minutes." And the code will work. The demo will look impressive. But here is what they will not tell you. They do not explain what an agent actually is. There is no architecture, no system design, no thought about how this ships. The moment you close that notebook and try to build something real, you are completely on your own. This series is different. We are going to build YUYUTSAVA, a real command-line-based coding agent. It runs natural language tasks. It reads and writes files. It executes shell commands. It can run inside a Docker sandbox for isolation. You can install it like any normal tool, with pip install. And throughout this series, every design decision will be explained. Not just what the code does, but why it was built that way. By the end, you will be able to build your own agent. Not a notebook demo, a real one. I gave our AI agent one task, in plain English. Understand this project, and write me a document I can read, along with data flow diagrams. Watch what it does first. Before touching a single file, it makes a plan. It breaks the task into 5 steps. Explore the structure, read the key files, create the document, generate diagrams, and save everything. It tracks these as a to-do list and updates them as it works. Then it starts exploring. It lists the project directories, finds a client folder and a server folder, immediately recognizing a client-server architecture. It goes deeper. It reads the route files, the model files, the configuration. It is not just listing files, it is understanding what each one does and how they connect. After working through the codebase, it updates its to-do list, marking exploration and analysis as complete, and moving on to writing. It drafts a full project breakdown, the architecture, the data models, the API routes, the authentication flow, and the data flow diagrams, all in a single readable document. Before writing anything to disk, it pauses and asks for permission. You approve. It saves the file to your results folder. One plain English task. The agent planned, explored, reasoned, and delivered a complete project understanding document ready to read. To understand what we just saw, let me explain the core difference between a chatbot and an agent. This is the concept everything else builds on. A chatbot is a single round trip. You give it input, it goes to the language model. You get output, input, model, output. Done. That is it. ChatGPT, in its simplest form, is this. An agent is fundamentally different. The model is no longer at the end of the chain. It is in a loop. The user gives a task. The model looks at it and decides, do I have enough to answer? Or do I need more information? If it needs more, it calls a tool. Maybe it reads a file. Maybe it runs a shell command. Maybe it searches the web. The tool gives back a result. The model looks at that result and decides again, am I done? Or do I need another tool? This loop keeps going until the model has everything it needs to give a final answer. That is an agent, not a smarter chatbot, a fundamentally different architecture. The model is the brain that orchestrates a loop, not a function that maps input to output. This loop has a name. It is called the REACT pattern. REACT stands for reason and act. Here is how it works in practice. The agent starts with a task. First, it reasons. It thinks about what it knows and what it needs to do next. Then it acts. It executes a tool call. Read a file, run a command, whatever it decided. Then it observes. The tool returns a result. The agent reads that result. Then it reasons again. With the new information, what should it do next? This cycle repeats. Reason, act, observe. Reason, act, observe. Until the agent decides, I have enough. I can answer now. In YUYUTSAVA, this loop is implemented using LangGraph, a framework that lets you define an agent as a state machine with explicit nodes. The agent node, the tool executor node, and the decision edge between them. We will go deep on the LangGraph implementation in episode 3. But right now, the concept is what matters. Every agent you have ever seen, AutoGPT, Claude, Cursor, GitHub Copilot in agent mode, all of them are running some version of this loop. The difference is in how the loop is structured, what tools are available, and how carefully the boundaries are controlled. Now let us look at the full architecture of YUYUTSAVA. This is the high-level picture. We will go deeper into each layer in the episodes ahead. At the top, the user. You type a task on the command line. That hits the CLI layer, which parses your input, loads your environment, picks your LLM provider, and decides how to run. Right now, besides Anthropic API, the agent supports Grok and OpenRouter, which lets you plug in any model. The CLI passes everything to the engine, which wires together the LLM, the backend, and the system prompt, and builds the LangGraph agent. Before the agent starts running, there is a safety and permissions layer. It has two parts: a filter middleware that controls which tools the agent is allowed to use, and a permission middleware, which pauses and asks you before the agent runs anything dangerous. Then comes the agentic loop. The agent node reasons, decides on a tool call, the tool node executes it, and the result comes back. This repeats until the task is done. Below the loop, the architecture splits into two sides. On the left, the execution backends. Local mode runs directly on your file system and shell. Docker mode runs in an isolated container with the same tool interface. On the right, the tool layer. And this is where it gets interesting. The agent starts with only one tool visible, tool search. Every other tool is discovered on demand. Task runner tools for reading, writing, and executing. Web search tools powered by Tavily and Exa. And skill tools that follow structured patterns. This is the overview. Every box here gets its own episode. Here is what this series will cover. Episode 1 is what you are watching right now, the concept of an agent and the high-level map of what we are building. Episode 2 goes into the full system architecture and high-level design, every component, every data flow, drawn out in detail. Episode 3 is where we open the code for the first time. We will look at the agent loop as it is actually implemented in LangGraph, the state machine, the nodes, the decision edges. Episode 4 is about tools and backend abstraction, how we define what an agent can do, and how we make it swappable. Episode 5 covers the CLI and packaging, how you take Python code and ship it as an installable command line tool with a proper entry point. Episode 6 is the Docker sandbox, why execution isolation matters, and how we run the agent's tools inside a container. Every episode builds on the last. By the end, you will have watched a real system, designed, built, and shipped from scratch. If that is what you came for, hit subscribe and press the bell icon so you do not miss any episode. We are just getting started.